tested recently?
Probably not, but now I will definitely have to go and have a look. Stan's Legacy.
Okay. It will blow your mind.
Yeah, yeah, because the Stan stuff, what really clicked for me was I just made the connection. I think I was probably watching like some of Ashton's stuff and learning about resonant LC circuits and just how that, you can resonate between the inductor and the capacitor, and then just joining the dots that, oh, that's what he's doing in this water cell, except the capacitor is the water cell. So he's just got the inductor outside, and then the capacitor is the water cell. That was the first leap for me, and I could see how that was working. There, you just pump energy into it and build the energy in the tank circuit, in the LC circuit, and then the next step was understanding those choke coils, and I think that's where the real magic happens, is in those choke coils.
That is correct.
But I I tried to build it and put it all together, but I've never really messed around with coils and electromagnetism stuff before. I couldn't even get my first inductor transformer working, and yeah, we've had to pack up and move house, so I'll have to dig all that out. I think I just didn't have enough turns on it. I only had like 10 turns on the primary, and I feel like maybe that wasn't enough to get the magnetic flux or field moving enough. It'd work in reverse. It'd work if I put power into the secondary. I could get a reduced voltage through the primary, but I couldn't get it to step it up through the primary to the secondary. So I've got to revisit that and then hopefully keep going from there.
Yeah, common
But yeah,
problem.
have you had with the VIC working? Oh, sorry, Chris.
I apologize. Yeah, that's a common problem with the
Reverse, it'd
mismatching
work if I.
of a primary secondary. Yeah, I've had multiple VICs working. I have designed multiple microcontroller controlled pulse generators. I'm working on sequence voltage attenuation right now. Um, if there's some way to put on video, I could show you guys. But yeah, I
I
do.
don't think we'd get video in here.
I have some code repositories on Bitbucket where I've got probably 5 or 6 different signal generators that I built over the years that you can download and um,
Awesome.
play on.
Well, I'm glad we've connected, and I can look into some more of your stuff there
I was just
because I
gonna
think
say. Oh, go
okay.
ahead.
No, go, Jim. I was just
Well,
rattling
finish
away.
your thought there, and then I'll riff a little second here.
Yeah, sure. I was just yeah. So when I sort of the penny dropped on how his VIC works, and he's basically just building this static voltage field and then that can split the water, almost for free. And then it looks like that's only like step one of the Stan Myers process. And then I feel like that static DC field, the ability to make that for very low input, and then you can do all sorts of things with that. I mean, it doesn't have to be water. I think he started messing around with other gases in his later inventions. That circular, whatever it is, magnetic plasma energy generator. I don't know what the word is, but I think he made some sort of custom plasmas out of that. And then it's kind of it'd kind of be the basis for the dielectric barrier discharge plasma generation. If you can build this nice static DC field, I just feel like that just opens up so many possibilities for things. So I'm keen to play with that and get that working. Yeah, over to you, Dinger.
Yeah, that's basically the setup of Stan Myers, from as far as I understand it, and Chris can go into it more detail. The coils that inhibit amp flow are where the magic happens, if I'm not mistaken, and that's what you're saying as well. And I believe that's super easily achieved with like the pulse attenuation. You said you got a circuit for that there recently, Chris, or Mr. Bake.
Yeah, yeah, for sure. Working on a basically just another Arduino controlled sequencer. You can typically use like a voltage regulator and hook a decade counter to it or something and actually get it to swap out resistances. So you're changing the voltage, right? I'm doing it logically with software on the Arduino, and it's just controlling something very similar to do that. So I'm experimenting with different ways to change the amplitude of each pulse train because that was like a phase 2 of what Stan went into. Um, the attenuation of the voltage was much more significant than the frequency itself.
Mm. Yeah, I was just getting into Arduino recently. I built that gas processor a while back, and I never finished up making a voltage source for it and putting resistors on it. And then that part's kind of scary for me, considering how little I am attuned to actually building bigger circuits and stuff like that. I'm starting small, but yeah, so it goes from, like Mr. Rotas was saying about the capacitive static field within the cell itself to inhibiting amp flow, which I thought I saw a video of yours, Mr. Rotas, pretty recently where it was like next to no amp flow at all, but super high or large amounts of bubbles.
So was that me? I don't know if I did that one. I just did the last video I just did was that little Tibby fusion replication, that little capacitor discharge across the foil,
No,
which is that
I
was
mean,
pretty cool.
Mr. Baker, he's got a
Yep, yep.
YouTube channel with. There was one I saw recently where he was showing the oscilloscope, I believe, that had pretty high voltage and next to no amp flow. I'll have to find it here. But that's the goal, right?
Yeah. Yeah, it's those choke coils. 'Cause I joined the dots with the LC circuit, and I thought, oh, cool. So that's how he's building the voltage in the water. The voltage that the water is the dielectric in the capacitor. But then these choke coils, I couldn't get my head around what he was doing there because I saw they were wound bifilar, and the only bifilar stuff I'd seen was Tesla's pancake bifilar coils, where he kind of constructively winds them. So if that makes sense, like each coil's kind of adding to the magnetic field, whereas the way Stan Myers had done it, he'd done them, I guess, deconstructive bifilar. So the coils are kind of fighting against each other. So with the Tesla style bifilar, you're making a bigger, you're amplifying the magnetic field, but with the Stan Myers choke coils, you're kind of cancelling the B field. And then that led me to think, well, we're talking about Tom Bearden here now. We're talking about getting rid of the vector and just making a potential. So you kind of got these two opposing magnetic fields fighting each other. You're making almost a compression in the magnetic field. So I feel like you're storing the energy in a scalar version of this magnetic field. So you can really pump it up then because you got no actual, what's the word, magnetic flux going through your core. So you're not going to saturate your core because there is no actual magnetic field movement, but you're able to store a tremendous amount of energy in this. I'm saying it's a scalar or what is it, potential, magnetic potential field. And so that's why I can just pump it up so high. It's basically, if it's all tuned up nicely, you're kind of unlimited, really, which is what Stan was saying too. You're only limited by your equipment as to how high you can push this. So the real hero of the story there is the scalar B field, in my mind. You're able to just pump these things up and store that energy in there, and that just holds the voltage in the capacitor. It doesn't let the voltage get out. It's just I find it amazing.
It's free energy from water, right? It's able to attract more of that universal atomic energy that Stan Meyer called it into the system just by being in resonance. Um,
Yeah, I think the voltage pulls the molecules apart. You're just pulling them apart. The same as what you're doing in the dielectric barrier discharge plasma generation too. I think you're just passing a fluid or a substance or a gas or whatever through this field, and that just pulls them apart. It gives them that additional energy or moves the electrons further away from the nucleus, and you get your plasma from that.
Yeah, like that's really the phase one of it. Like you could consider it highly efficient DC electrolysis for phase one. Perhaps even disassociation below the breakdown voltage due to resonance. Um, Stan's whole point of resonance was about getting the highest voltage out of that circuit possible and the lowest current, obviously. However, there's a phase two at work, and it was responsible for what he called a geometric yield gas progression. And that was literally once the initial disassociation occurred, we were left with free ions floating in the water, HO negative and H plus. Those are now electrically attractive and repelled from the voltage fields. Those were put to work and caused to bounce back and forth between the cavity at a specific frequency that matched the wavelength of the cavity, causing a perpetual oscillation of the ions smacking into the
Ah,
molecules and busting them apart, producing a tremendous
is that what he calls his
electric.
cascade? He calls his cascade effect or something, doesn't he?
He, what, yeah, he calls it particle oscillation as an energy generator. That's like his main tagline for it, but that's really what's going on. He describes it like bouncing a laser between two mirrors before it's released out. You can imagine the zigzag pattern of it. Well, that's effectively what the ions are made to do, and it's the voltage fields, like you said, exactly the scalar fields of voltage without current flow. that cause that influence them to bounce around.
So is that in his resonant cavities? Because I saw he made like a spherical, had a couple of different ideas there. One of them was like a sphere with an internal cathode or anode. And I guess if you sort of tune the whole system, you can hit another form of resonance within that cavity itself. And that's sort of what you're saying there. It's resonating the ions that are left over in there. Is that what I heard?
Exactly. He attempted to enact momentary entrapment of the ions and the bubbles in general, because the longer he could keep them in there, the more work he could do with them. And yeah, that's exactly it. It was
And they can use more energy into it, I suppose, can't you?
the way he described it.
Yeah, it's all just about resonance.
Yeah. Yeah, he described it like it would continue to produce an increase in yield, and the only way that you could stop it is to stop adding water back to the tank, and so on. So the spherical cavity was like a 3-inch and a 1-inch concentric spheres. I've got a couple here that I've made, but they were all about that, was to keep the bubbles trapped in there as long as possible.
Yeah, and I mean, I've bought some little stainless steel spheres and some different stuff to play around with. Once I finally get the Vic working, I want to explore all that different stuff. I made a HHO cell I made out of these cookie cutters, just from, I don't know what the equivalent shop for you guys would be, but just like a Walmart or whatever, you get these stainless steel cookie cutters come in a set of 12. And I thought, oh, they're nice. They're concentric rings. They're about 2 mil gap between them. So I've spaced them and hooked them up to wires and everything. And so that's my HHO cell. And it works just with straight DC. It works pretty well. So I'm happy with that as a cheap way to get going. But yeah, I just need to get the electronics working behind it. But yeah, just everything we're learning here, it's all just about resonance, isn't it? Every sort of system that's got any level of efficiency, it's got to be resonated somehow.
Yeah, for sure. The Stan was real big.
And
on
then
sorry.
No, I'm sorry, Chris. I keep talking over the top of you. You go. Stan was what?
We have a little bit of lag. Yeah. No, I just wanted to say that, yeah, Stan focused on using 304 stainless steel, specifically because of its iron content and because of the annealing process. When it's made, there is silicon and chromium in there, and there is a type of passivation that occurs, or conditioning it's referred to, as the water contacts the electric surface over time, and it does set up a Helmholtz type layer on there, and actually behaves more like a diode, and that's responsible for a lot of it. So it actually becomes magnetized. Stan refers to it as the atomic infrastructure of the metal itself becomes polarized. It becomes magnetic over time. So the iron's really important in the metal that you use.
Yeah, right. That's a pretty technical level for me to understand right now. That's pretty interesting. I just wanted to get into it as quick and easy as I could without much investment. I was trying to find that stainless steel wire as well, because he specifies that for the choke coils. I just made mine with just the normal magnet wire to start with. But I was trying to trace down that stainless steel wire for the choke coils. That seems like a bit of a hard one to come by. I found a supplier in China, but you got to buy like a 10 kilo minimum order or something like that. Have you had any luck finding that stuff, Chris? I'm sure you have. Yeah.
That's the exact experience we've had. Some people have bought some of the original stock from Don Gable. If you know who he is, he was the guy who handled Stan's estate and some other stuff. But yeah, we've got similar quotes from that. Stan, when you mentioned bifilar and those chokes, Stan did create pancake coils. He did stack them horizontally for a distributed effect, but then he also wrapped magnet wire under them in parallel in a sense, and he used both in conjunction. But the resistance wire was to, the more resistance you can increase, the higher your Q factor will be, more amp choking will occur.
Yeah. Yeah, I just see that. That just opens up a whole world of possibilities to build that static DC field that can then be applied to a lot of different things.
We do have a Discord server if you're interested in joining. We have a lot of guys.
100%. 100% interested in joining that. How do I find that?
I think you can just search for Stan's Legacy on there. There's a link on the front page of our website. I think you can get there.
Yep. Nice one. That's always good.
Yeah, there's a lot of guys in there that are learning, and some older ones that we have like a running group we've had for about 6 or 7 years now. Some core guys that have been working on it.
Yeah. And then the laser beams as well. He gets some like infrared lasers going, doesn't he? At some point,
660
I think he does that. Yeah, yeah. So he's hitting the after you've disassociated the water and you've got your hydrogen, then he's hitting the hydrogen with this 660 nanometer light energy as well, isn't he?
Photon energy aids resonant action. Resonant action is
Uh-huh.
that term for that particle oscillation I mentioned.
Yeah. And so is he with the lasers? He's doing that in the cavity too, isn't he? So he's getting. I guess he's trying to bounce the light energy around in there too.
Yes.
And do you pulse those lasers? Because I was trying to think, like, how do you drive them? Do you just hit them like as a standard, they just switch them on, or does he actually pulse them with a frequency? And what's the relationship of that frequency to the VIC frequency?
Mm-hmm.
Is there any relationship with that? Do you know?
Yeah, there was a gate drive. The circuit that produced the gate signal, the gate clock to turn on and off the main pulse signal. During he included inverters on every board, so we always had an off channel that was Q and not Q. So he would then take not Q and use that to turn on pulsing for the LED. So those got gated pulses also.
Yeah. And was that in? So that was not at the same frequency as the VIC, but it would have been some derivative of that, I'm guessing.
He states 0 to 1 kilohertz, and it was fired off cycle from the pulse train. Yes.
Okay. So he might have been running the VIC pulse at like anywhere up to 10 kilohertz.
Right.
But then the laser's an order of magnitude lower than that by the sound of it.
Typically under 10 kilohertz, but we have references to 1 megahertz beyond.
Yeah. Yeah. Do you know anything about the Joe cell, Chris?
A little bit, not a ton.
Yeah. I've watched a couple of little docos on it, but it sounds like I think he did some initial conditioning, but then it didn't have any power input afterwards. And I just wonder, did he somehow set up like that cascading type situation we spoke about earlier?
Yeah, I'm not sure. That would be like a multi-series capacitor, with all those concentric rings. What would actually be going on in there? I don't know how he drove it that well. It was a pulse frequency.
Yeah. No, nor do I. It just looked like a bit of a curiosity. I haven't dived into that one fully. But yeah, and I don't know. Did you have anything you wanted to say, Chief? Or?
Yeah, sorry, my daughter's screaming in the background. She just tripped. But
No worries.
the
It's fair enough.
yeah, the pulse circuit driver is my problem, and it's been my problem for a while because it's not necessarily like you just flip a switch and it turns on. For me, anyways, like you gotta make some kind of operational amplifier to drive the circuit, which is the VIC in totality. But what gets me is the fact that nobody really just, at least in modern electrical engineering and stuff, nobody admits that pulsing is just more efficient all around because it leads to oscillations and resonance in totality. So it's just odd that it's not exactly a wildly known thing. It should be everywhere. Like Joel Legacy is another guy I look to for information, and he has a video called Secrets of the Back EMF, and it's simply that the radiant energy all around your system will fill the void when you pulse a circuit. And when you do that at a certain resonance, whatever your circuit ends up being, that resonance will, decrease amps and increase voltage. What does Stan say? Basically to infinity if the components will allow it. So we could be living just based off of magnetic resonance, but that's not, up next on the chopping block per se. But there's so many ways to gain energy.
I can't. Whereas I feel like modern electrical engineering, they probably like when they're designing power lines or whatever, they probably check for resonance as like a safety thing. Like they don't want resonance, they want to avoid resonance and add things to eliminate the resonance. Whereas we're like, no, give us all the resonance. That's what we want. Let's go investigate that part of it.
Yeah, it's like, well, the 120 volt 60 hertz AC is the resonance they want. They don't ever want that moved. So we put in all these breakers and fuses to make sure it never fluctuates beyond that, which it's good for closed systems, but um, it should all stem from an open system. We shouldn't be just using closed systems for energy generation, but it's kind of a side story. Um, yeah,
Yeah.
the Stan
Yeah, I
Meyer.
was thinking about that with AC power versus. Sorry, you go, Chief. Go, go, go.
You probably had a better thing to say than me. I was just going to say the Stan Meyer process
No,
is like resonance in water, basically. It's creating a supersymmetry effect between the cathode and anode to break apart the um, hydrogen and oxygen molecules in the water. So it's all about resonance and creating that static field. But again, static fields aren't exactly that well mentioned or um, talked about in standard electrical engineering. So go ahead.
no, I don't kind of think to make a static field sort of convention takes a lot of juice, which is probably why when I think of like the Nazi Bell and all that, you hear all this had these huge power cables in there, and it was driven off these massive power supplies. And I feel like they're probably just brute forcing that DC field for that, if that's how they had it working. Whereas using resonance in like an LC circuit, you can build pretty much an equivalent DC field, but for very cheap or almost for free using the resonance of the system. But that's the trick, isn't it? Sizing the capacitor with the inductor perfectly at the right frequency. That's where I feel like there's a bit of a scientific process. I was just using a little square wave generator to try and get it going, but I don't know if that was the most appropriate thing to do either. I don't have an oscilloscope or anything. And again, my ultimate idea was to have like a little Arduino system that could just drive this thing. It could generate the signal, it could monitor the amp inflow, and then I'd have it hunt for the right frequency based on the amp inflow. So I'd have like a little amp meter feeding into the Arduino, and it would be trying to search for the lowest amp flow by varying the frequency. So it could be like a bit of a dynamic frequency hunting system. That was my idea, but we haven't got there yet.
Yeah, I actually built something very similar to that. It generates the frequency and controls the circuit. It iterates through, every possible parameter that it could. It's some pretty extensive functionality with the logic controllers that I built. But not only that, then it takes input from amp sensors, and it actually talks to my scope over the network and pulls in all the probe readings, so I can monitor and log voltage. And I built, like graph dashboards to display it all and stuff. And so I've done a lot with that.
That's just a whole nother
That sounds
level
incredible.
that I'm trying to get to right now. Like the Arduino coding it's what, like C++, but it's also specific to the brand Arduino or something like that. I don't know. I'm not classically
Not
trained in
really.
computer science.
Not really.
It's a whole different programming language basically, and it has like the idea
Yeah.
of talking in ones and zeros doesn't make sense to me.
Well, the thing here is, like I played with Arduino a few years ago with my son when he was little, and you can get these, these sort of logical programming systems where you can kind of drag and drop the ands and the ors and the different things, so you can build up your code that way. But these days we've got ChatGPT and Grok and that, and you can just talk to them and say, "Hey, write me an Arduino code to do this,"
I know I don't
and
want
that's
to
going to
do that
get
though.
you 90%. You don't want to
No.
resisting the AI.
Yes. Not at all turns, but at a
Yeah.
lot of turns these days. I don't want to use AI. I feel like it's ruining social media in a broad sense, and I just feel like it's, I don't know. I don't want to become the Borg, but not to say that people that use it are the Borg. It's just, um, right now it's annoying me. I'll say that. So.
Yeah, no, I feel you on that. But I'm also like, when I was trying to design this cell, I'm like, if I can ask Grok, hey, can you calculate the capacitance of this system or calculate the inductance of this system? And it can just punch out the math where it'd take me probably, hours in a textbook to work it all out, and it can just punch it out. Now, whether it's accurate or not, I don't know. But for me, that's a bit of a game changer if you can have almost a robotic electrical engineer on standby. But yeah, I definitely get you when everyone's just like, "Hey, Grok, what do you think of this?" Or they give you some bloody AI response. It's a bit much at the minute, isn't it?
Oh yeah, but um, the Arduino, I don't know. Is that like the end all be all for pulse drivers? You think, Mister Bake?
No, in fact, I'm disgusted with its latency and lack of consistency and precision
Yeah.
and low CPU. Um, well, it's great. It's definitely the economy approach, and it'll get people testing and playing around for cheap. We're trying to build this immense control, supreme flexibility over everything. Like more knobs than you can imagine. I have pointed at me here. Just to get that done. And then like when you finally find out exactly how it needs to be, you could make it small enough to fit in the palm of your hand, right?
Right. Yeah.
Yeah, you got to tweak all the variables up front before you figure it out, I suppose, don't you?
Yeah. There's not
Right,
a
because
whole lot of. Sorry. Go ahead.
there's just so many variables to tune around, especially with custom transformers, that you can easily be inhibited by a circuit component that you have, and you don't even know it because you just don't have that flexibility in something to even test where you need to be in the ballpark.
Yeah. It's the Arduino doesn't have a whole lot of inputs, and it doesn't have the power ratings required for really um, advanced efficiency in electrolysis systems. But so what am I trying to say here? I guess the pulse width modulation is the thing I'm searching for. Is just the general driver circuit right now. What would you say is best for that? If it's not the Arduino, or is it the Arduino and I just have to like eat it?
My most ideal results have came from the ability to have a good, high quality external signal generator, one that I can customize waveforms and so on, and then go through the Arduino for a hardware based counting system. So I have a counter which basically does the gate clock on and off, and that gives me my perfect pulses. Otherwise, you have all this clock drift. I've spent years just trying to battle clock drift on different things. And that was the solution I came up with, was to have a counter at the hardware level, right? It gives it bandwidth up to at least 1 megahertz. So it's been pretty useful in that sense.
Just using it as like a switch.
Yeah, a counter and a gate clock create generator.
So I could have like
So do you have like a, you getting a,
I was just gonna say, so I could have like a transformer that has a transistor in between the prime or the secondary output, and use the Arduino to gate it, perhaps.
I would gate it going into the primary, but yes.
Mm. Yeah, that makes more sense.
and so what do you have like a triple five chip driving your initial signal, Chris, or do you have something more advanced than that?
That's definitely what Stan did and what Max did. But no, I actually have a Leader LFG 1300S. I have two of them sitting side by side. So they've got internal amplitude modulation where I can basically make one gate the other one. So I could do that. But I'm just really just using one into my. I have a three Arduino setup here going. One does the counting, makes the gate signal. The second one does sequencing. It splits it across two channels. There's a triple AND gate made out of MOSFETs that I have that does my signal reproduction. And then there's a third Arduino that's doing this amplitude attenuation by sequencing that LM317 power supply. But they're all in time because they all watch each other and they all trigger off of the master clock and so on.
That sounds intense. Do you post videos or updates in your Discord or anything? Can I see what you're up to, or what are you up to?
Yep, 100 times a day.
Okay, cool.
Yeah.
There's another guy I've come across on Twitter. I think his name's like Colby or Corby, and he's got that company. Is it TOBE Energy?
Yeah.
It basically sounds like he's doing Stan Meyer's technique, and he's trying to commercialize it.
For sure. He started out friendly. He joined our Discord one time, hasn't been back since. Him and I spoke on the side a little bit about stuff. We talked on a call a little bit. So he's a pretty bright guy. He's going after some funding to try to get it off the ground. But he told us that he was going to release it all and open source it and show everybody what he was doing. And we're still waiting for that to be the case.
Yeah, I could imagine when the commercial aspects come in, he might want to hold it a bit closer to his chest if he's trying to make something out of it.
Yeah, but to be honest, that's what got everyone nowhere all these years.
Yep. No, I'm just watching to see, if he gets some funding, if it gets happening, or if it's going to get pushed to the side. I don't know. And yeah, the other way. So I was thinking that stand, like you could probably get into the stand stuff fairly cheaply and start playing around with it at the low level. What you're doing, Chris, sounds a sort of next level stuff. And my other entry point into all this exercise, obviously, was the ultrasonic cavitation with water and aluminium, following Bob Greenier's ULTR experience. And I think that's the next thing I'm working on now. I'm going to put the other one to the side, but I've got a couple of ideas on how to try and make something more out of that. I think that's got some potential too. And when I go back and look at like these old rock carvings and stuff we have on the ground, even like the swastika symbol and all these symbols on megalithic structure, I feel like some of them are actually blueprints for how to build a machine to do this. Because I feel like this, we can access the ether and this free energy. You can do it with bloody, what is it, attosecond lasers and high voltage fields, but I also think just vibrating water might be another way to get there too. A much more simple, low tech way to do it. So I got some ideas there. I'm going to what I found with the just using the little jewelry cleaner there, putting a can or another shape in there, you can sort of build a resonance chamber, and I can actually make two. I can have one in the can and one outside of the can, and when you get it working properly, I believe we can actually make a wheel in the can and a wheel out of the can. We can get the two wheels, and we can start building up that fractal toroidal geometry in there with a minimum of two wheels, and start getting some next level Tor action happening. And because we're doing it with water, it's slow. It's not like high energy plasma. It's water, so I can actually sort of see it with a high speed camera. You can see what's going on. So I think that's another great way to see it. So I've got this idea that those you'd probably be familiar with this thing. You're a welder, I think, aren't you? But when they make exhaust pipes, you can buy these exhaust donuts, basically like a torus of steel. So I'm going to get a couple of those and cut them up, and I'm going to try and replicate the geometry of the fractal toroidal geometry. Get a couple of piezo transducers on each of these and set them up in the right pattern. And I reckon I've got an 80% chance of learning something really cool, and maybe like a 20% chance of something extraordinary happening. So that'll be the next project over the next few weeks. It's really about a $500 outlay to get all the stuff for that one. So I'll start acquiring all the bits and bobs there. Yeah, what I've seen in the water cavitation, I think Stan actually talks about it too, and so does this other guy, George Wiseman, because the water molecule itself's already polarized a little bit with the oxygen and hydrogen at opposite ends of the molecule. Stan talks about on his process of pulling the water apart, there's like this intermediate step where the water's sort of stretched more, but it hasn't split yet. So it's like this electrically excited water, and that's also what George Wiseman talks about. He has the HHO for health. He breathes in the stuff and uses it to make the water torch. But he also talks about this electrically expanded water. And I think I've seen that in my experiments. Is like I haven't been confident enough to post it publicly, but I probably will at some point. I'll just keep looking at the footage. But there's definitely this other substance in the water, and it can travel above the water and below the water. But it's like, yeah, it looks. I think it shows up on the camera because I think the camera can see infrared. But it's like a metallic sort of. Well, it's made spheres. It's made little bloody plasma orbs out of it in my videos there. So I think we've got some of that going on in there. And my thoughts are, if we can generate whatever this is, this water plasma, cold plasma, electrically expanded water, that could then be fed into more machines to do work for us, as whether it is a pseudoplasma or an actual real plasma. I think that's another exciting potential there if we can make some way to generate this substance and then use it further.
Well, I think Mr. Bate can speak more to that, but that's kind of the gas processor step on Stan's thing in general. You get the electrodes in the water bath producing the HHO, and then from that you take another electrode with pulsed light around it to further increase the atomic destabilization, which is quasi-plasma like, I guess. You're further exciting the steam and HHO that comes off. So Mr. Bake, I'm sure, would have more experience in that end. Have you set up a gas processor?
Yep, I got one right here. Two of them, actually. Yeah, so there's a lot to unpack there. The atomic equilibrium, I think Stan called it. The Yeah, he was all about orbital velocity attenuation. That's one of my favorite phrases. But slowing down that electron valence orbit, right? And that's what weakens the chemical covalent bond. Um, and that happens only from voltage, right? But like it only persists for a very short time. As soon as the field is removed, they will go back to stable. There's an alignment that starts to occur. The water does start to magnetize, starts to polarize. However, polarization lags the electric field, right, because of viscosity in the water. So it takes a long time for them to align and then begin to take on a charge and then begin to elongate for the bond to be weakening. Um, but then, yes, he did take the ions and the gas or whatever afterwards as it was escaping and subjected it to another set of concentric tubes with a field, much more high voltage field, and now it's steam or vapor at that point. So the voltage can rise significantly higher. And that caused the ions to take on a higher energy charge, start radiating energy, and so on, and then bouncing around, or and causing a lot more. I think he had a much higher thermo explosive yield when he was able to charge them up right before prior to ignition and so on. That way.
So the gas processor, is that where he takes the ambient air just from the atmosphere, he puts it through a DC field to, I don't know, I guess he's making ozone. He's kind of making a plasma just out of the ambient air. So this is getting to his later invention where he had whatever it was, that little injector where he had the three inputs. One was the ionized ambient air. One was, I think it was just water vapor, and the other one was a bit of hydrogen or HHO. Is that correct?
It was intake air that went through the gas processor, so it got charged up. It
Yep.
was water from the water tank, and it was EGR gases from the engine. All three of those
Oh,
mixed together
recirculated exhaust. Yep.
because that slowed the burn rate for him.
Yep.
Yeah.
So it sounds like he didn't have to generate a huge amount of hydrogen with that process, did he? Because he was sort of getting it, he was using the ionized, or I guess it's basically a plasma from the air, I'm assuming. And then that's able to then interact with the water and these exhaust gases.
Right. Right. You could, if you had ionized air and introduced it just into the water bath, it would almost disassociate on its own, just because all of those ions are missing electrons, and they would link up and they would steal the covalent electron.
Yeah, so when we say ionized air, that's a plasma, isn't it? Ionized air is plasma or not?
I don't know that I'm an expert enough to say yes or no, but it seems like it.
Okay.
It's
Yeah,
definitely,
yeah.
you know, I, before Stan, my focus was on Tesla, and I'm really familiar with spark gaps and how that whole thing works, and what goes on between them, and how ionization of air and quenching is used to control a frequency out of that. Um, and it is real similar from what Stan was doing. So, you can do things to quench the gap to reduce ionization.
Yep. Yeah, and the other one that's really tickled my interest as well is Walter Jenkins and what he was doing. So it sounds like he had a sort of similar approach, but instead of using a HHO cell, he just missed the water with a megahertz, one of those little misting piezo crystals, but he'd do it at a high frequency, so to generate a really small water droplet, really small mist. So it had to be like a megahertz, 1.7 or 2 megahertz frequency crystal to do that. And then he'd feed that vapor through, I guess, through a strong DC field, essentially.
Yeah, but I think he also mixed gasoline with it too.
Yeah, he put like 10 mil of petrol on top of the water, I think, just to give it a little bit of extra
Hmm.
oomph.
Well, it was probably to help slow the burn rate is the main problem.
Possibly, yeah, yeah.
Hydrogen burns at 325 centimeters per second, but that's not HHO. HHO burns significantly faster. It's like 5 meters per second. But Stan was able to reduce it all the way down to that of alcohol or propane, like 30 to 40 centimeters per second.
Yeah.
That let it right down.
Yeah, the level of technology Stan developed absolutely blows my mind. I just thought initially when I knew about him, I thought it was just he split water, but he took it so much further than that. And what he had ready to go for the whole world would have been incredible if it had got up.
Yeah, I agree. You familiar with the steam resonator?
I don't think I've looked into that one. No.
Yeah, it was another type of cell design that used that used non-simultaneous polarities of electric fields, sequenced non-simultaneous polarities, and it was able to superheat water for almost no current.
Hold on. So what does that mean? What did you say? Non-simultaneous polarities?
Non-simultaneous polarities. So if you think about like a firing order of two electrodes, you would hit one with B plus, but not the B minus on the other side. And then you would stop and turn
Uh-huh.
off B plus, and then you would apply the B minus to the other side. So it was just
So it's
using
still got
voltage attraction.
bias across, still got the same bias or direction, but you're just applying to the different electrodes. That's what you're saying?
It's not at the same time, right? They put it was at
Yeah,
the same
yeah, yeah.
time,
Alternating. Yep.
it would make gas, right? You would current would flow or whatever. But without that, it causes, and what I think is that it was the disruption of the hydrogen bond. You know, if you rotate the atom, he describes a back and forth rotation similar to how a microwave heats water, and that broke the
Yeah.
hydrogen bonds, and they would reattach when it turned off, and that would cause, um,
Heat.
it to make heat. Yeah, I've got a replica
Amazing.
of one of them.
Yeah. Have you guys built that?
Yeah, we got all the 3D printer STLs are all on our website. You could download the whole thing and get it machined, all the specs and everything. Some of that secret stuff that we got was literally all the design specs and drafting specs from out of his technical memos that were never
Wow.
before. So the injector.
That's incredible. And so has someone made a functional gas generator? A steam resonator, sorry.
The unit, yeah, the cell is sitting right here, but and I've been working forever on my the Arduino circuit I told you about, the controller, because it has that second one that does the sequencing. That allows me to
Uh-huh.
send pulse to one side and one pulse to another side. So it's a matter of developing the driver circuitry to suit the rest of the arrangement. But I have the control circuitry built for doing just that and what it needed.
That's incredible.
You can actually turn that into a transformer and transistors to do the switching, to get that actual effect of the non-simultaneous polarities. It's actually very hard to do, number one, but two, and prove it with a scope. How do you probe that? That's a very good question. Because you need current flow and voltage drop to probe something, to probe a differential, so you can't probe differential.
Yeah, right. So you're almost using an AC waveform then, and you're just hitting it with the positive on one side and then hitting it with the negative on the other side?
Yeah. There was multiple firing orders, so there was some that only used positive on both sides at the same time, or only negative both sides at the same time. There was multiple firing orders he had for it. Yeah. They were all
Oh,
effective.
wow. I'm just struggling to even think. So if I put positive and positive on both sides of a plate, what am I doing there? Am I making like what kind of electric field is that generating?
I don't know. I mean, it's basically that it said that ions are disassociating all the time in the water. So there's always a portion of them in there in any water, right? So a voltage
Yeah,
field is going to have some effect on them.
yeah,
Performs work.
yeah. I think this high voltage stuff's probably where it's at. Like you think about the alien reproduction vehicle, and the way I understand that working is basically just it's got a ginormous capacitor at the bottom, and it's generating million volt DC fields, and that's where it's able to interact with the ether at those high levels. And I think this high voltage is where it's at. Yeah, I just another topic I've been really curious on, and one I want to chase out at some point is I had someone comment on a YouTube video that reminded them of flow forms from permaculture, which I'd never heard of before. But then I looked up these flow forms, and it's kind of this this idea of activating the water or getting the water to flow in a natural way and that sort of thing. But these flow forms, they're sort of shaped in that figure eight, like the Visa Capices kind of layout there, mirroring the fractal toroidal geometry and the shape of that sort of thing. So they're promoting the water to flow in this figure eight pattern. And I'm thinking, from what I've seen with my cavitation, when you can get two of these, when you can get a figure eight happening, you can get this next order of Tor structure happening. And these flow forms, apparently, they add a heap of oxygen into the water, and they can remediate the water, breaking down some contaminants and that sort of thing. So I think it's replicating a natural purification process that happens in streams and that sort of thing. So I want to have a little look at that, because I'm thinking I'm a civil engineer by trade, and we do a lot of work with stormwater drainage systems, and a lot of that work walks around treating that water, whether you put it through a wetland or they call them rain gardens and that sort of thing. So you're sort of filtering this water through plants so you can discharge it into the creek and it's nice and clean. I'm thinking if you could add one of these sort of systems, these flow form systems, we might be able to get more contaminant reduction just by using this natural process. So I think there could be a real, again, that's a really simple application of this sort of technology to achieve a real world outcome. And I could see that being a thing, we could implement that in our stormwater systems somehow. I've tried to do some research on if anyone's sort of looked at taking dirty water and running it through these things and seeing before and after. There's a little bit of research out there, but there's one paper I found that absolutely, it's a head scratcher. So he's done. I'll see if I can find it and I'll share it on X at some point. But he's got 3 setups. So he's got just the base water, like your control water, another system where he runs it through 16 flow forms, another system where he runs it through like 30 flow forms. But he's got this other system in the middle where he runs it through the 16 flow forms, but he's built a dodecahedron shape out of brass poles around the outside of this thing. And then the results for that one with this shape around the outside, it's like 30% greater than the others just from having this shape on there. And then I just kind of think about Dan Winter's stuff and what's going on that you can build a shape out of brass and that improves the performance of a system. I'll have to find that one and post it on. I'll post it on this thread here. But yeah, I think there's so many applications for this technology we can use.
There are a lot of rabbit holes. The waters have been muddied quite a bit by people doing a lot of amateur experimental stuff. We all are trying to learn. So it's hard to say. I've tried to steer away from like the more metaphysical stuff, like ooh, I felt energized. It's like you can't prove that.
Yeah.
Looking at it on the scope.
Yeah, I think there's an element of faith as well, though, isn't there? Like you got to jump into it and believe that it's true, and then there's also the hard science of proving it's true too.
Right. Yeah.
And what about you, Dinger? I want to hear more about your negative electricity and electret experiments. What have you been up to there?
Well, it gets to this what Mr. Bake was talking about with how do you measure a potential itself. The electret is a static electric field itself, and if you pulse it, it's supposed to give you like a hysteresis effect where it's super high voltage spikes with you can just put a low spike in to get a high spike out basically, and that will give you a pulse on your amp or your capacitor to charge amps and deliver current to whatever you're going for. It's a work in progress, but the thing that came to my mind when you were talking just there was the space between a positive and a positive plate. That just becomes something else entirely, right? Like that's a pure potential in some sense of, how do I say this, just thermoelectric disruption. Like you're only going to cause a bunch of chaos and heat in this little zone when you're pulsing it at the same polarity in this whole space, right? So that's kind of like the electret as a whole idea in and of itself, is that the space is charged. It's just to a specific polarity. I don't know, that was a lot, but
Did you make did you make your own electret? Did I see that?
Yeah, so what gets me is it's laxative. This is from Joel Agacy, and he calls it a negative resistor, or what else? Memresistor or something. But hypothetically, I haven't done enough experimentation on it yet. It's still curing. Hypothetically, it's a room temperature superconductor. And that's crazy to me because it's literally laxatives.
What do you mean? Is that what it's made out of?
Yeah, Miralax. I heated up some Miralax with a little bit of water, and then just for giggles, I put some graphite dust in it. And we'll see how it turns out. I was pulsing it / conditioning it with a little high voltage transformer discharge, and I've been continually doing that on and off throughout the last 4 or 5 days I've made this one. Yeah, it's interesting because I have the electret, and then underneath that I have a magnet or two magnets with a coil beneath those magnets, and I get what I understand to be a radiant field discharge in the coil. And that is uncoupled from the power supply of the electret pulse. So it's supposedly like keeping the dipole open and allowing yourself to have like a one wire circuit almost. That's the goal with this. But like I said, the driver circuits seem to be the key for me. It seems to be like you need some kind of measuring pulse, or you just need to pulse width modulate from the beginning to basically achieve your outcomes, whether it be highly efficient electrolysis or resonance in general. The pulse width modulation is the thing to manhandle.
Yeah. Yeah, the electret thing is interesting. I'd never come across that till I saw the plasma channel guy. He made one, and it looked like he sort of used like a polymer of some sort or a polycarbonate or some sort of plastic, melted it, poured it into a mold, and as it was setting, had a strong DC field around that material. And so my thought there is, this whatever the fluid or the material he's using, that plastic, because that's setting in the presence of a big DC field, those molecules or atoms are probably stretched or stressed in accordance with that electric field. So then when it sets, they still hold that stress or that state, and therefore they've got a permanent electric field set up there. And so then you've got this little plastic puck that you can move around that contains a little electric field in it. I'm curious about how you got some magnets in there too, though. So is your idea there you pulse your coil, then as the coil collapses, you get a radiant electricity spike in your electret? Is that the idea?
Yeah, but kind of in the opposite. So I'm going to pulse the electret to get a spike in the coil. And from how
After it's conditioned, you mean?
Yep, after it's conditioned. I was
Yep.
conditioning it, I saw that the coil was getting like 400 plus spikes. And of course I had the transformer going while that was going on. But it's interesting just to have, like, I'm a welder, right? So I always have to have a positive and a negative. I have to always attach my ground clamp. There is no direct connection. It's just like hovering electricity. I don't know how else to describe it. It's really, really odd.
Yeah.
That's
Yeah.
what we call a freestanding resonator.
Really?
Yeah.
Yeah, it's interesting. I didn't think, crystals and crystalline structures and stuff like that was that important, but it seems to be the key for all these subquantum mechanics and electrodynamics.
It's kind of wild when you try to think you're a technical man of science and you end up talking about crystals. I love it.
Exactly. We have it's made out of crystals.
Yeah.
Yeah, and that's the other thing is these like speakers and transducers and stuff are literally crystals, right? And that's what's causing the aperture to move up and down is the wiggling of the piezoelectric.
Yes, but what's even below
Exactly, yeah. So what's below that?
What's below that?
What do you mean? What's the actual mechanism in the crystal that's making it work? Is that what you're getting to?
It's the ions, right?
Yeah.
Ion transfer.
Probably.
Because that's what happens in a transformer. That's what happens in a conductor. Stan was all about that. Literally, he focused on building up positive copper ions and stripping off the copper electrons, and clustering them to do the ampere band.
How does hydrogen relate on? How do you think hydrogen relates on the universal scale to that idea where it clusters and bunches up based on like temperature gradients? Because to me, it seems genuinely, if the sun is a hydrogen atom, and I know this is kind of going into maybe speculation and stuff like that, but if the sun is a hydrogen atom, holy smokes, that gives us like a physical mechanism to go out and reach for stars. Literally, like, say we're in the middle of space, we can throw out a hydrogen molecule that will go and immediately superconductively attach itself to the nearby or to the nearest hydrogen atom, aka star, and be able to be, travel faster than light. But that's just if hydrogen is like this fractal in and of the universe itself. I don't know. It's a weird thing to think.
It makes me think of Bob Greenyer when he talks about the Arecibo message. I don't know if you've seen that stream he did there. So that was like that crop circle where we sent out, allegedly we sent out a communication into the cosmos, and then we got a response, 7 years later. But the response was basically a fractal hydrogen atom was their method of communication. We put a little picture of our telescope or whatever as to how we communicated, and then they responded with this fractal hydrogen pattern as the response as to how they communicated.
That's interesting. Right? Oh my God, that's crazy. I haven't heard of that, but I just thought of like these crop circle things keep popping up on X every now and then, and you look at them and you're like, oh my God, that is an insane drawing. There's no way some farmer made that. These farmers ride in autopilot tractors. It's not being made by, I don't know. That crop circles are crazy. Where was this transmission received?
I think they're all in England. They seem to be mostly all in England, but it was, I don't know. Again, I'll have to find it and dig it up.
Yeah, I remember. Like,
so yeah, I think crop circles are either a really elaborate psyop by the people that have this technology already, or it's like some natural or alien phenomenon. That's where I get to. It's either an elaborate psyop to to get us confused and thinking about aliens, or it's legit communication from somewhere else.
100%. I'm 100% in agreement. What you said, Mr. Bake?
just agreeing with you.
You're really quiet again. I hate to
sorry.
bring it up.
I don't have the greatest setup here.
There we go.
I mean,
yeah.
So I'm probably going to have to take off in like 20 minutes or so, Dinger, if that's all right. We've got to get on with real life as well in the background.
Yeah, no problem. I guess the other thing I wanted to get to quick was the, like, hold on, let me read this here. I was reading, I guess I'm not supposed to share it online because it's behind a paywall, but it's the work of one Paulo Carrera, how is it said? And it's from like 1980s, and it's all about plasma fusion and compression, and they have here it is. They have a device that claims 487% over unity. Now, that is absolutely nuts, and it comes from the idea that, just reading this here, low field emission, unlike prior art, planar or coaxial electrode discharge devices utilize short gap and high field discharges. In the absence of an unexploited electrode area effect, the pulsed anomalous glow discharge reactors are essentially low breakdown field devices with large gaps and which advantageously employ the voltage reduction electrode area effect to substantially decrease the field strength. The breakdown field values typically span from 5 to 30 kilovolts per meter, and field emission theory requires a very high breakdown field factor greater than 2 to the 10 I forget how you say scientific notation, 2 times 10 to the 9th volts per meter. TLDR, low field emission breakdowns can cause pulse spikes in the vicinity, in the state space, aka it's similar to Stanley Meyer's work in the sense that it's creating an area of effect within and around the electrodes to generate energy instead of just, like moving a motor or something, like a magnet around a coil. You're actually sending out a signal to get some signal back. TLDR.
Mm. It made me think of I was reading up on dielectric barrier discharge and trying to get my head around what all that meant, and I found one example where this guy had a Jacob's ladder, the two sort of V-shaped wire, and then you have the spark that travels up there, and so that'd just be a normal spark gap discharge when you've got the spark gap in there, and so you've got actual current flowing through the spark in that instance. But then what he did is he put a sheet of dielectric, like plastic or glass, in between them, and it would still glow and generate plasma, but there'd be no current flow. So he was like blocking the current flow with his dielectric plastic or glass, but there was still glowing plasma in the presence of that electric field, which is that cold plasma. So again, you're getting more efficient use of your energy. You're not using amps, but just the electric field is enough to excite whatever medium you've got there. That's what I was thinking of when you were talking there, Chief. They're using like a dielectric barrier
It's funny you say
sort of
that.
thing.
Yeah, that's it's so the field that the electrodes are in becomes the dielectric barrier, and it's saying in low breakdown potentials. So when there is a glow happening, it's anomalous because it ends up producing spikes in voltages that are way exceeding the input voltage. So it's like if we just allow our system to be opened, whatever the system is, it seems like any circuit, if you just have like a spark gap, you can have pulses that are extremely higher than the original input.
Yeah, but it sounds like they're not making a spark, though. Is that right?
No, so it's a. Let me read it again. It's sorry that was a little brutal, but it's a AP PAGD, pulsed anomalous glow discharge, and it's a low field emission. So they're creating an aluminum argon plasma in a tube that's again in low breakdown. So it's glowing just very uh, they say abnormally, and it's darker than you would expect like a high voltage plasma to be, but they're still getting
Mm.
the high voltage spikes. So it's the field effect, and it's the fact that it's in non direct coupling. It's not directly attached to the cathode or anode. It's not directly coupled to the anode, cathode, anode, whatever.
Sounds interesting. Yeah, I'd like to have a look at that. But it's like, once you've made the plasma, I mean, the plasma is superconducting in itself, and then the plasma is probably doing some weird stuff outside of your electrical circuit. That's probably doing something for you.
Yeah, I was gonna ask like Mr. Bake here what the implications of having like a conductive container around the water bath would be. Like if you didn't have an insulator, like plastic or something, if it was like a copper barrel you set your electrolysis system in, what do you think that would do? Because then you're in like physics calls it incompressible mediums, but it's a compressible medium that you're pulsating with electricity. So I'm just curious what you think would happen there with a conductive
There,
container.
yeah, if you're pulsing it with high voltage, there's going to be a massive field that comes off of it. There's going to be leakage everywhere. Sitting on a table leaks. Putting your hand up against the cell makes it leak, and you can watch the waveform dampen down. Um, a copper thing, in my mind, is going to cause it to just suck all the energy that might be in there out. One of the things that Stan did was encased it in high dielectric strength Delrin in his cavities, really thick stuff, to try and keep the energy inward, focused on the actual chamber, as opposed to leaking outwards. So I don't know about like what would be escaping, and then like if you reflected that back in, maybe, but it seems like it would just short to ground because this is electrostatic properties now, principles, not necessarily traditional current flow, or you would think like that. So there is going to be charge leakage and corona loss, and even if you can't see it or know it's there, it's still there.
Yeah, how would you like even measure that type of stuff? Because like you were saying, it's like it's a pre-potential, and I think Tom Bearden called it engineering the cause rather than the effect. Like the radiant energy coming off of the electrodes is um, well, the radiant energy coming off of the electrodes is the cause, and then using the effects in your favor to, you know, be in a certain frequency and voltage. But the cause itself is the oscillation and radiation of the inner cavity part, not the necessarily direct application of the current. If that made sense.
Hmm. I'm not sure.
Yeah. Sorry, that was a little brutal.
I just-
I just know it leaks to
yeah,
ground, and if your goal is to build up voltage, you don't want it to leak to ground. Any means possible. One point on what you were just talking about before that, though, the dielectric barrier. Stan didn't really do that per se. He had like a different concept where he made he called it a stainless steel sandwich, where he layered stainless steel plates and he made a resistive binding mixture that we think was maybe electronegative or something. And he claimed that like basically lifted the voltage breakdown threshold to infinity, so he was able to send as much voltage as he wanted to it. But there are also, in addition, a couple other patents by a guy named Tae Hee Han from the Philippines, where Stan spent some time. Anyway, they use this principle where they put a dielectric divider between the cavities. So there's basically electrode, water, divider, water, electrode, right? You think of it that way. And the
yeah,
concept is that the electrode, that the barrier, the divider, has a higher dielectric than that of the water. So the high voltage will come through across the water and it'll smack into that dielectric and it won't be able to jump to the opposing electrode because it will be stopped. But the voltage alone will still be able to take effect on the water in some fashion. And
yeah. So it's like the field can still go through, but the actual there's no spark or no voltage, no amperage going through, but the field can. Is that's what you're saying?
right, and the VIC can generate significant voltage very easily. The problem is
Yeah,
if you hook it to your cell, you're loading it down and you're conducting current, and the voltage is dropping. That's why people don't get high voltage. But if you actually
yep,
prevent the current flow, you could achieve super high voltage. I've gotten kilovolts out of mine, doing that.
yeah, no doubt. I wonder there as well because there's two ways of splitting water. One, they use like a membrane in between, and so then you can siphon off the oxygen from one side and the hydrogen from the other, or the others you just have no membrane between and you get the mix of gases. What you're suggesting here with the dielectric could kind of you'd be able to split the gases doing that, wouldn't you?
Yeah, presumably it would ionize the high voltage field, at least the positive one would ionize it. Stan went as far as to do equal opposite voltage for a dual rail, where he put a B minus of the same equal voltage. He claimed that was maximum current restriction would occur in that sense. Part of what the chokes were about was to getting that B minus equal to the positive. Um, but yeah, it's going to have an influence on the water even without current flow because voltage alone can perform work. As you get to the plasma state,
Yeah,
you introduce free electrons into the water, and that can that directly causes destabilization.
yeah, yeah. I learned a few things with that Tibby capacitor discharge experiment too. That was interesting. So you're just taking a capacitor charged up and then discharging it between two bits of aluminium foil that are separated with a thin layer of water. And what I found there is it's quite sensitive to how thick that layer of water is. If it's too thick, you'll just it'll just be like a mini electrolyzer for a second. The capacitor will discharge and all that energy will go, and you'll make a couple of bubbles, and that'll be it. If the aluminium's too close, it'll just arc across, short out, and you don't get anything happening. But if you get that sweet spot where you've got just the right amount of water gap between the aluminium foil, I think it does a little bit of electrolysis, and then it does a little spark, and that's where you get that um, plasma reaction happening there. So if you've generated a little bit of hydrogen and then you've introduced the spark and it sets off enough that it can start generating those little plasma whirlwinds in there.
Mm-hmm.
So getting that
That's now.
getting that mix right.
I'm really curious if anybody has actually analyzed the gas that has come off of something that was using plasma or having that big high current spark through it, because according to Stan's stuff, he's basically saying that him and another guy, Stephen Horvath, who patented basically the ability to use the square wave signal to it, and it was all based on improving the inefficiency of adsorption, which is where the ions collect along the electrode in conventional DC systems, and you start to, that's why you have to push more current is to overcome that barrier, that Helmholtz layer of ions that get adsorbed to the electrode. Um, so the most efficient thing you could do is turn the signal off for half of the time, and that allow time to release or force quench it or push it through there. Um, but Stan basically said that uh, that doesn't occur with his because number one, the voltage, uh, it's only because he's pulsing it basically, and then because he's
Yeah,
causing
the pulse train. Yeah.
and so on. But then there's, if you ever listen to his brother talk, he did a few radio interviews on Kentucky
Yeah.
Forestry Museum for James Roby, and he talks about the Fermi level, which is a concept of how the first diodes were invented, and he sets it against the electrode itself. So remember, I said there's an atomic structure in the electrode. And the annealing process for making 304 stainless is such that you have this kind of p-n junction, right? But with the water coming in contact with it, you also have a p-metal junction. And if you can succeed in elevating, if you're familiar with the Fermi layer, it talks about how there's this sea of electrons on which the Earth floats. Sorry, who said that? But it's basically a layer of a conduction band, they call it, and it's a layer in the metal physically where the majority of the electrons exist. But there's a barrier on the other side of that that's up close to the surface, right? So when you make any electrical connection, you make one of two types of connections. You make a resistive connection or you make a diode-based connection, right? So in DC systems, we
Yeah.
all for the lowest resistance possible, and we the biggest conductors and all that. But that's still fighting a resistive connection. When you have a diode with the P water junction, you have this different type of effect that sets up a barrier there, right? So Stephen's all about it's a barrier technology, right? And you basically create a mini diode or a diode along the surface, and it's the overtime polarization, the perhaps chromium oxide coming off, creating this PN junction type layer along the electrode that I think people refer to as conditioning. But
So when you say it's like a diode effect, it's only a one-way effect, is it?
yeah, it has rectifying like properties, yeah. But if you can succeed
Yeah.
in bringing that Fermi level of electrons up to the surface, so you can move that Fermi layer level or layer, it's called both. You can actually cause that to, and you do it through voltage biasing, right? You bias it up to the surface, and then the electrode, and then the electrons can flow from it. You can pull electrons out and get them into the water. He says. So it's a little
Interesting.
controversial. Stan doesn't really talk about that much at all, but that's
Uh,
that's his angle on it.
it gets so technical, doesn't it? Like chemistry, and you're getting right down in the details.
It does.
Makes me think because I've heard again Bob Greenyer talk about some of the experiments where they're making plasma, and they talk about they have a DC bias, and then there's a pulsed AC signal or a pulsed signal as well. So that sort of aligns with what you've just said. Maybe that's related to that. And then the other one that popped into my mind there, I was watching some dude that made his own Tesla coils. And these Tesla coils, they had a pancake as the primary down the bottom, but they'd make this out of like thick, like 1 inch copper pipe, because apparently there's an edge effect for electricity where all the electricity travels around the edge. And I guess that's kind of what you were just saying there, wasn't it?
Yeah, definitely. Stan would talk about skin effect and stuff, but it was more
Skin
like,
effect, that's the one. Yep.
yeah, but he was more kind of describing it as like traveling waves, and the tubes were a wave guide. So it was the standing waves that build up along the electrode that were perhaps responsible for that resonant action, pushing the ions back and forth and so on.
Yeah, I was trying to, because I can understand resonance of acoustic waves, like that makes sense to me. I can see that and I can understand that. But if we're talking resonance of electrical waves,
Yeah,
that's it. Again, is it the same principle as acoustic, but it's just happening a lot faster?
well, it's like you can think of it as a open-ended dipole antenna, right? The two concentric tubes. Um, so there is an RF aspect to it. There's a harmonic aspect to it. There's there's uh, charge distribution along the surface of the electrode that can be considered. There's a Helmholtz effect, which is the spacing between the electrodes equaling the diameter that can lead to full saturation. But then there's also Stan's secondary resonance, which is the gap or the width of the gap, which is 1/8 inch or 1/16 on each side. that was specifically tuned to the voltage or to the frequency that he was bouncing those back and forth with. Right. So that's a third type of another resonance that was occurring, a perpetual oscillation that he was targeting.
Yeah, so much areas to optimize, isn't there? So many things to tweak and play with.
Yep. Lots of rabbit holes.
Well, what I'd love to do, I've just got in my mind, what I'd love to do is have a megahertz mist generator, like your Walter Jenkins, just megahertz mist generator, generating some tiny little water particles, feed that through a dielectric barrier discharge DC field. So hopefully we're exciting that water, or maybe splitting a little bit of it, or getting something happening in there, and then feed that through a thunderstorm generator or a geat into an engine. And I wonder if you could get away with running a car on water, or potentially like Walter Jenkins did, you put a little bit of hydrocarbon in there as well. Would you be able to get enough out of that to almost run an engine on water?
Yeah.
Maybe throw in a couple of lasers as well. Who knows?
Stan's injector was able to do it with 5 microliters of that water fuel mixture. So it was very little water per cylinder fired.
Yeah, it's amazing. And I think in one of the videos I saw of him, he did a demonstration to someone, and I think it might have been when he had his buggy running on the injectors, not just on hydrogen. And the noise of this buggy, like it sounded like a performance bloody NASCAR or something. Like the explosions, the noise it was making sounded very powerful.
That's right. That was the tapered cavity design, where he found that when you have these parallel concentric tubes, then you have an average yield. But when you taper them, you have a more explosive than heat yield. And then vice versa, when they are expanded, you have a more heat yield than explosive yield. And so he went on to multiple applications for that. He had industrial furnaces, and he had rocket engines
Ah,
and so on that he put that in. He had, but the spark plugs were tapered on for that reason, to cause that massive explosion right at the tip of the spark plug, so that there was no time for nitrous oxide to build up. And
so if you're tapering the electrodes, is that what he's doing?
right, it was, and
So
that
you're
wave,
making, sorry.
the waveguide, it was effectively tapered, so it all came to a head at the point, and a kinetic vibration at the last second happened and caused it to ignite.
Yeah, right. So is it a waveguide, or are you just making a stronger field at one end than the other end?
He talks about it being a compressional waveguide. So as it reduces, the compression causes the voltage to go up and causes the energy in the atoms and make them vibrate more. And then this kinetic vibration triggers the ignition.
Uh, I wonder if we taper it at phi ratio, are we going to get something magical happen there?
Yeah, I don't know. There's just so many
You
different
might teleport the
applications.
water away to another dimension.
Yeah.
It's like all the applications, right? I keep thinking about how Stan Meyer's process is like the process we could use to pretty much one up or level up all of our everyday lives. It seems like you could have it in the
Yep,
fridge, even like you were saying,
Needs
in your
all
furnace.
needs.
I mean,
100%. That's what attracted me to it too. I thought if there's a quick win for humanity, that's it. Like if we can generate even just splitting water cheaply, like that's enough to change our whole paradigm of life, let alone going to the next level of Chris, because I remember him talking about hydrogen fracturing, and I was trying to get my head around what he's talking about there. Is he actually talking about like he split the water into hydrogen and oxygen, and then he's taking that hydrogen atom and he's splitting it down again into maybe, I don't know, quarks and gluons or whatever? Is that what he's doing when he's saying that?
Yeah, he tended to not like to refer to subatomic particles so much.
Yeah,
He
yeah,
kind of thought they were mumbo jumbo, because it was early at the time. But
they probably are.
that whole process of taking, once we have the ions or just the H by itself, perhaps, uh, the as the field, as he charged up the atom even more, this he was able to get at this stuff called universal energy. And if you think of the nucleus as a vortex, it's a toroid in a sense, but the whole thing is an energy vortex through the middle of it. Um, when you slow that electron down and you stretch it out to an outer valence orbit, you weaken that bond, but you also cause the nucleus to expand. So Stan says, science asks, why does not the electron crash into the nucleus of an atom, right? Science, and I don't know who, Newton or whoever, said that basically it has to. the electron emits a field, right? And it has to be moving so it can continuously keep itself away, right? Well, Stan says the
Yeah.
opposite.
Well,
Stan says uh, that the electron, yes, it wants to crash into the nucleus, but the nucleus is open just a little bit, and it's releasing this universal energy, and that's keeping it, it's pushing it, and keeping it out in its orbit, in its particular valence band or particular other band. So as you use voltage to stretch it to the outer band, this equal reaction is that the nucleus opens up, and he it even begins to modulate. So if you're modulating the voltage to move that electron out and then release it and let it go back, this constant excitation and relaxation that we know of, right? Then and don't take it to ionization to where it's ejected, then you cause that nucleus to open and close and to be modulated itself. So and it will release this universal energy that he says. The atom is an energy transporter. It's a conductor of energy from other dimensional universes, even. So it's a little mumbo
yeah.
jumbo for Stan, but
No, that's awesome. That's getting to like the hydrino hypothesis and Hal Puthoff's ground state of a hydrogen atom.
yeah,
That's all linking into that. That hydrino stuff's interesting. That sounds a bit like what you're talking about there. But it even comes down to, what is gravity, what is time, and all that sort of stuff. Like, is all our matters in this constant state of having 0 point energy flow through it, and that's what controls the rate of decay
right,
of an atom. Like, a nuclear atom will decay, have a half-life of whatever 20,000 years, but if you change the vacuum pressure, you could change that half-life, increase or decrease. And I guess that's governed by the flow of ether through the nucleus, which is what you're saying there. So you can, wow,
you'll
so you can modulate the flow of ether.
you'll be interested to check out memo 4302, which is the atomic degaussing process, where he used a hydrogen flame produced from the electrical polarization process to give electron donation to radioactive isotopes and reduce their half-life almost instantaneously.
Yeah, I wonder. I'll have to dive into that because when you can draw parallels to other people's work, sometimes it just clicks and makes more sense because you got people were treating radioactive material with Brown's gas because Brown's gas can generate the fractal toroidal moment, which would lower the vacuum pressure in that area and allow these molecules to decay rapidly to a more stable form.
Right.
That
And
sounds similar to that, but he's saying he's giving electrons, he's donating electrons or something.
right, right, because in the water, when it's running right, it makes this red gunk, this red stuff that looks like blood in the water. It's real oily, right? It's not the brown and yellow gunk that
Yeah,
you see, right? It's red. And if you do it with distilled water, it's really easy to get it because the voltage can get higher, obviously. But what that is a redox reaction, right? So the same thing, I think, is what he says is what occurs in the with the nuclear waste. It ends up being reduced because it's giving it electrons from the hydrogen flame that's burning, or sorry, even without burning it. I think it was just the gas he was saying to do either.
yeah.
A lot of weird
Oh man, I wish his stuff had come to fruition and come out. That would have been incredible. But I guess here we are. Got to pick up the pieces.
But these ones are far fetched, right? Like these are like some seriously advanced stuff, and a lot of people get stuck on, oh, well, what am I gonna do with hydrogen, right? They think I got to run a car on it. Well, that's a feed in itself, right? People shouldn't be focused on trying to run their car down the road so much as like, hey, we've got super efficient electrolysis for one, and we can do things like make a flame and heat water. We've got Stan's quenching discs here. We had a machine. We got them made in China for $1 a piece. It was ridiculous. They're to precision 9 thousandths of a diameter holes in them, right? Made out of aluminum.
Yep.
So they're very strong and they're very high quality. But anyway, everybody focuses on like I got to run my engine, right? Well, that's a big job, right? And you got to spend a lot of time getting that to run. It took Stan a long time to get it to run, but like then we're focused, or at least I am, and others on this steam resonator concept because like how much more economical and how much more how revolutionary would it be if you could just heat a pot of water to superheated boiling in a matter of seconds or minutes for a very low amount of power, as well. That would
Yeah,
be
and then you can
game
hang a
changing.
turbine off that, and you're good to go.
It would be game changing, yeah, for whatever
Yeah.
reasons. So yeah, I mean that's a lot more like something like that could be put to use right away, and not have to figure out how do we handle hydrogen safely and how do we not blow myself up and all this stuff.
Yeah, yeah. There was another water heater I saw that used, I think it was more sort of a cavitation type design. It ran, well, no, there was electricity in there too. He had like two, almost, I'm thinking like stainless steel salad bowls. That's what comes to my mind, like these two sort of half spherical bowls positioned with a distance between them and then an electric field between them. And I think he was super efficiently generating water. Or there was another one where it was running water through it and it was cavitating. I'd have to go back and have a look at these, I think.
I believe I saw that one, and from what I think remember is like he had to dump water that was already up to like 110 degrees into it, and then he added a
Right.
little 9-volt battery onto something that like kickstarted the reaction. Now, I actually did it with DC. Stan has a design which was a horizontal resonant cavity that used circular electrodes, and the gap with them was specific. But I was able to make heat with them with just static DC. And it
Mm.
was because of that momentary entrapment that I was telling you about. The longer you can keep the gas in, or I'm sorry, it was because of the quenching. So it's trapping the water in there. But if you don't like feed new water through, right, to replace it, it will make gas up until the point that uh, if you don't trap if you don't send new water through, it'll make this gas, but then it'll transition after a certain point and start making steam, and it'll instantly boil the water. So I did like for what it turned out to be 3 watt minutes. I was able to boil a 1 inch cylinder of water to so hot that the hot glue melted and the plastic pipe deformed. you know, with
Yeah,
3 watt.
right.
I have a video on YouTube about it.
And that's probably, I'm sure you did the calculations on how many mils of water and how many degrees and
Yeah,
how
it
many
was probably
joules it should have taken.
conduction, but it was eye opening to see that what it taught me was that when we tried to make steam with a conventional cell, that new water coming in to quench what was ever going on, the little bit we were able to maybe heat, we were losing it. So the point was to try and trap the water in that sense and not let new water replace it. And that's when I saw that I could make it heat up really, really fast instead of just making gas. Because DC shouldn't boil the water; it should make gas. But at some point, it turns into steam and boiling, and no more gas. And that's why I'm curious about
Yeah, I wonder what the
electric.
mechanism there was.
That's why I'm curious about who's testing the gas that's
Yeah.
coming off of like plasma detonations and stuff. Because Stephen and Stan both say that what's coming off of there is literally 85% water vapor and only 15% hydrogen, right? Conventional. And if you use the pulsed DC method on there, it actually transitions to more orthohydrogen than parahydrogen, more explosive, and it's now 99.97% pure hydrogen. So it's 8 times more gas by volume. It went 15% up to 97% hydrogen. And so right there is an efficiency that nobody even considers with what's coming off of that cell. Sure, it's nowhere near as much gas liters per minute, but guess what? It's 8 times more explosive. just
Yeah,
from
yeah, it's going to do more for you. Yeah.
yeah, a lot of misconceptions about it just from not really knowing.
Yeah, yeah.
Are you guys
I'm certainly
talking
going to have to
about
dive into
using
this further.
sorry to jump in. Are you guys talking about using water as fuel for ZPE?
For any reason, I guess, as fuel or as electric generators. Yeah,
Yeah,
I
that's
guess
that's
we're
a
just
pretty
sort
good
of
idea.
shooting the breeze.
Yeah, the idea is that you can get energy, electricity from water, but at the end of the day, everything is powered by this universal zero point energy. Like Chris Bake was saying here, the neutron atom, or the neutron nucleus of an atom, seemingly has this like loophole moment or uncertainty principle or whatever you want to call it, to where it can be oscillated, expanded, and captured in energy circuit to give you more than you put in. And that's what zero point energy is in a nutshell, in a bad explanation. But water itself has this polar moment of the oxygen and hydrogen to where it's already somewhat polarized. And if you simply flip it back and forth in an electrode, you can gain more energy in your system by the water adding to it. So that's where the water fuel comes from, and that's you can also take the hydrogen off of that water and combust it for, you know,
Yeah.
conventional combustion engines. So it's
Yeah. Regarding. Oh, sorry.
it's a double step process there, I guess.
Regarding the universal energy, he called it a voltage controlled one way gate valve for that universal energy to come out. So it was completely controllable because as soon as you wanted to turn it off, you just had to shut off the voltage.
That's crazy. Yeah, he really got pretty deep in this stuff, didn't he? It's incredible.
Yeah, I've been hooked.
It's interesting because if you take like an atom and you try to just like make a macro scale atom, um, a plasma bubble is that. Like it's got um, a moment of ignition to where you have to ignite the gas around your bubble. Let's just, if you're in a hypothetical sense with me right now and you're building like a plasma bubble spacecraft as a macro representation of an atom itself, you're having a bubble that ignites from a certain area and is continually fed from a certain area, but also stands as a standing wave in a dissipative zone like a flame. So there's a point that it reaches and is actually dissipating energy, like a voltage controlled one way gate valve. Um, so it's super interesting how like Stan Meyer's a never ending rabbit hole for me, and I'm sure Chris you're in the same boat because just how applicable the process is. It's like everywhere you could use this, from instantaneous hot water and giving the world free food and free hot water to running your car or jet plane on it, or even spaceships. Like the hydrogen um, aspect to space flight is sorely unappreciated. Like we can have warp drives and all that, but the hydrogen plasma aspect comes into play on another level. But that's another story. So yes, water fuel and 0 point energy are linked.
I was just sniffing around for some other stuff the other day as well, and I found this new term called plasma-assisted combustion, which I think is kind of basically what Stan was doing with his injector there. It's probably what it looks like what Malcolm Bendel's turbine might do as well, where they've got like they pass a gas through a dielectric discharge and generate some plasma. Then they also inject a bit of fuel into that too. Also similar to the other one I want to look at is those plasma spark plugs. I think there's a guy, what's his name? Is it Aaron Murakami or something like that? He looks like he's got a good. Sorry, boo. Someone said, "Hey."
I apologize. I couldn't help myself. Yeah, Murakami, he's a handful.
Yeah. I've got no idea what he's like personally, but I've just had a look at his idea and his sketches, and the plasma spark plug. I think that's got a lot of legs as well. I think that's what Walter Jenkins is doing. So he had his water droplets coming in, and then he'd ignite them with this plasma spark plug.
Right.
So that might be another way to do it. Yeah.
So refueling this around the universe would be a lot easier than if you needed like nitrogen and shit. Water would be the easier natural go-to.
The most stable form of energy storage known to man.
Because I've been stuck on nitrogen for a while, but literally I've been just in here for like 5 minutes and I'm already like, yeah, I'm kind of retarded. Water is just like, it just makes so much sense.
Make it on demand and you'll never blow yourself up.
Yeah,
It's pretty wild. We got.
Go ahead.
You go, Chief. I was going to say it's pretty wild. You got hydrogen and oxygen bonded together in this perfectly stable, safe form that if we can pull it apart, we then got this explosive mixture we can use, and it'll return to a nice stable form again afterwards. It's pretty miraculous, really.
Yeah, I was just gonna add on top of that and what Chris Bake said, the most stable energy dense, or what'd you say, the most stable energy dense molecule known to man. I forget.
Just the most safe and stable energy storage method, basically.
Yeah. Yeah.
Because like we consider hydrogen as an energy store, they say it's a great energy store, which it is, right? But then you always want to transduce it to something else. But water in this case is even better.
Yep. Yeah, because
I think water's got a lot of mysteries around it. Like there's all the stuff about memory in water and all that sort of stuff too. I think water really is, and structuring water, I think it's a lot more special than we take it for at the minute.
yeah, it's kind of freaky to me how some of these experiments with water have been uh, suppressed because I tend to look at some of the open secret science, as Nathan calls it, um, and just go like I tend to take that as with more respect than some of the stuff that comes out of like Harvard or wherever the hell, and some of these water experiments are just bananas, like taking DNA in one cup and moving it through water into another cup, or um, what's the other one where you get sonoluminescence, wa- light from a cavitating bubble of water. I mean, it's just water is a beautiful thing. The other thing I was going to say is, water is like polarized naturally, and I think you told me this, Chris, that Stan says oxygen has some kind of natural hunger to it. Um,
If
I
it's
think
missing more electrons, or yeah, it's got 2 electrons missing by default. Hey, sorry, I need to run for like 5 minutes. I'll be back, guys.
no problem.
No worries,
Thanks.
man.
Um, the uh, the splitting of the polar bond of water is, a super energy dense function. It releases a lot of energy when you do it, and it maintains its structure pretty well. Water does, so it's a fairly energy rich. It's the most energy rich thing, like Chris was saying. If you have that as your base, let's say, like water is the base for your electrolysis splitting idea, you can think of water and hydrogen being throughout the universe and being able to split that itself, which is a I know this is getting into the non-energy sector of this, but I believe you could probably split water across the universe, and I mean that in the sense that you could take the electrons and bunch them together in like this poly trap that I've come across before, but just recently been fascinated with the idea that you can bunch ions and electrons in like the same space but in opposite phases. So like you could have your oxygen over here and your hydrogen to the left of it, and then a oxygen on the left of that hydrogen. So you could have them lining up longitudinally to create a more dynamic or gravitic or energy dense effect just within the water itself. Like that's what the electrodes are doing in a conical formation versus like what you were saying, Mr. Rotas, with the sharp edge idea. Is like the if it's in a conical formation, you're kind of imploding, quote unquote. But if it's in a like edge formation, it's more so disrupting. And either way, the splitting aspect of it is the important part.
So how well would we be able to use just oxygen as fuel for this some type of device like this? Is that possible? Would we ever be able to use just oxygen? What do you think?
I'm
Well,
not sure. Really.
yeah, beyond just oxygen, you could just have, like, if you have. Well, it depends on what you're trying to do, right? Like the battery requires the circuit, and the circuit requires the battery. So if you're trying to get free energy from any element, you have to have some kind of fluid gas recirculation effect where it's constantly running over a cavity or a plate or an electrode or a cylinder or something to capture the electrons that are moving from A to B and harness the potentials that are naturally flowing in and out of that system. The the thing about circuits now is that every single circuit on the planet kills the dipole with no amplification or um, rectification. So you're killing your circuit constantly by having the pulse or the positive go into the negative. Whereas if you just take that signal that you're creating, sending, maneuvering, if you take that signal and maneuver it to uh, an asymmetric type circuit to where it's charging and discharging at the same time, or charging up over in the cell. I'm kind of getting lost in the sauce here. The point is that everything has an electric potential and is using or moving electrons, And you could use oxygen, you could use hydrogen, you could use copper, you could use aluminum, you could use anything that's in the universe for some form of energy. It's just like, what do you want to do with it? Because the uh,
I guess I'm trying to make like uh a a wormhole.
no big deal. Well, that's a whole different thing entirely, I guess. The spooky action at a distance is a real thing, and it's also being used in water, I guess. That's what I was talking about earlier with the DNA through one cup into another.
Yeah. And to make a wormhole, I mean, I'd just be looking into the Bob Greeny's fractal toroidal geometry. My understanding of a wormhole there is you set up the wheel within a wheel structure. Within that structure generates a white hole and a black hole, and that is your wormhole, is the white hole connecting to the black hole. Now, they can be right next to each other, or they can be far apart, across the
So
universe or whatever.
right now I'm having just a hard time deciding on the fuel pretty much, and then I'm working on the capital right now on the meantime.
Yeah, right. Exciting stuff. But I mean, in terms of fuel, at the end of the day, E equals mc squared, energy equals mass times the speed of light squared. So anything that has mass has got a lot of energy. So anything could be energy, depending on how much you want to pull it apart. But I guess there's different levels to that. And we can just pull apart water into hydrogen and oxygen and use that as it is. Or you could keep going and pull apart that oxygen and pull apart that hydrogen further and release that energy that's inherent in the matter. Yeah, but right, I'm going to have to run, Chief. This has been awesome. I've really enjoyed this, and I hope we can do it again sometime soon.
Yeah,
Thanks very much for organising it. It's been really good. And nice to meet you, Chris. If you're still there, I'll jump onto the Discord and check out your Stan's Legacy stuff. I remember I've had a look through the website, but I didn't know you had the top secret files. I'll have to go and find those.
Yeah. No, thanks. It was nice to meet you too. Looking forward to seeing you in there.
Nice one.
Yeah, awesome. Thank you,
Right.
both Chris's. It was awesome as well. I don't have much to add. Thank you so much. I would just say, Mr. Bake, I would love to just get this Arduino set up. Like, I know it sounds stupid, but I'm still stuck on the coding functions and stuff like that of it. And even just sending a pulse signal to the electrodes I have would be, I imagine, some kind of increase in production. So maybe if I could get, well, I'll just go to Discord for all that. But yes, thank you guys. This was awesome. I'll see you in Discord probably.
Cheers, Chief. Really appreciate it. Bye-bye.
Thanks.
Big Tuckus!